Okay, so tomorrow you have a test. The test will have 16 questions on it. Two of them are going to be proofs that you're going to write yourself. Now I'm going to go through section by section, tell you what to focus on. This review is a good way to study for tomorrow's test, as well as go back through your warm-ups, your homeworks, things like that. All right, so from section 1, this is where we learned the triangle sum. It's called the Triangle Sum Theorem. And remember, all that stated was that the three angles of a triangle add up to be 180 degrees. So know how to apply this. If I give you two of the angles, to try to find a missing angle. Or if I give you expressions, know to take each one of the angles, add them, and set it equal to 180. The other thing we learned in this lesson was the exterior angles theorem. And that's what you're using to solve numbers 2 and 3. Okay, so just remember that the two non-adjacent remote interior angles, the sum of those two, when you add these two, it's always going to equal the outside. Same thing here. If I were to add these two, it will equal the exterior angle. Also, be able to, just like you did on the quiz, classify the triangle. Now, the question on the test is going to be different from what the quiz. Remember, the quiz, you had to give both names in the same question. I'm going to separate it. I'll probably give you a question where I'm going to say, classify it based on the side lengths. And then another question will say, classify based it on its angle measures. So remember, the names for the sides, when you want to name a triangle based on its side lengths, the first one is scaling. And remember, that's when all three sides are different. Then the next one is isosceles. And that's when you have at least two sides the same. And then we also had equilateral. Then giving it a name or a classification based on its angle measures. We can call it an acute triangle. We can call it an obtuse triangle. We can call it a right triangle. Or we can also say that it's equiangular. Equiangular. So these would be the names based on its angle measures. So be able to come up with one of these names when I say classify it based on angles or classify it based on the side lengths. The other thing we learned in section 1 were the corollary to the triangle sum theorem. So the corollary, and again, I'm not going to ask you to list any of these and explain them. Be able to apply them, okay? Or be able to use any of these theorems as reasons in a proof. But again, I'm not going to ask you to explain and tell me the name of the theorem you're using, unless it's a reason in a proof. So we learned the corollary to the triangle sum, and that was the acute angles of a right triangle are complementary. And remember, complementary means that the two angles add up to be 90 degrees. So be able to apply that. So all of that was from lesson 1. So be able to find missing angles if I give it to you as an expression, whether it's the interior, whether you're looking for the exterior, any of this information from 5.1. From 5.2, and then all these problems that are here, 1, 2, 3, 4, from section 1 in that little section there, these are all good ways to practice. Again, if you're looking for additional practice, go back. Look over your homework. Look over your notes. Look over the warm-ups. Now, in the warm-up, we actually graphed order pairs, and then we had to classify the triangle after we graphed it. You're going to have to do that as well on the test. Now, I know it's not in the review, but we did it in the warm-up. We did it in the notes. So be able to graph 3 order pairs, create a triangle, and then be able to classify it. Then in 5.2, this is where we learned the third angles theorem. And we also learned the properties, which we've seen over and over again. We learned reflexive, symmetric, and transitive. And these were all for triangles. We've seen them for numbers, for segments, for angles. We've seen it multiple different ways, but now we just apply it to triangles. So that was what we saw. We saw these 3 properties reintroduced again in section 5.2. So just remember that when you're given a congruency statement, that's going to tell you the order that everything matches. Then in 5.3, this is where we started to see our first shortcut. So we learned the SAS, or the side, angle, side, congruency theorem. So this was our shortcut. Again, when you're writing this as a reason and a proof, all you have to do is put SAS. We also learned the definition of what it means to be an included angle and an included side. So just be able to recognize when it's the included angle, because we need that for side angle side. Okay, if an angle is marked and it's not the included angle, then you can't use side angle side. And then when we got to the angle side angle, that's when we use the included side. So be able to look at pictures like numbers 8 and 9 and tell me which shortcut you would use to prove the 2 triangles are congruent. Then in 5.4, you should know the parts of the isosceles triangle. So for example, if I draw an isosceles triangle, remember the 2 congruent side, that's a leg and that's a leg. This vertex that's up here at the top, this is called the vertex angle. And then the 2 at the bottom that are across from the congruent legs, these are called the base angles. And this side that's different, this is called the base. In this lesson, we also learned the base angles theorem. And that was if the 2 sides are congruent, then we can say the 2 angles opposite them are congruent. Then we learn the converse of the base angles theorem. And this one stated that if the angles are congruent, so if we have 2 congruent angles, then the 2 sides opposite them are congruent. So the base angles theorem states that if the sides are congruent, then the angles across from them are congruent. And then the flip of that, if the angles are congruent, then you can show the sides are congruent. We also learned the corollary to both of these, to the base angles theorem and to the converse of the base angles. And that just stated that if it's equiangular, or actually if it's equilateral, then it's equiangular, and vice versa. So if it's equilateral, then it's also equiangular. If it's equiangular, then you know it's equilateral. So they'll give you pictures like this. So if they start out with congruency marks on all the angles, on all the sides, then you know all the angles are congruent. Or if they start out by saying that all the angles are congruent, then you can go back and say all the sides are congruent as well. So that's all that corollary stated. So this was a corollary. But again, you're not going to have to identify if it's a corollary. Be able to apply it if you're looking for a missing side length or a missing angle. Then in 5.5, this is where we learned the SSS, or side, side, side shortcut. So just be able to, if I give you a picture and I say, what shortcut could you use to prove the triangles are congruent, be able to recognize which one you would use. Also be able to write a proof, maybe just like this one. Yes. Here, what they like to do is they like to state their given separately. I like to put mine all in one step. So this could have actually been a 3-step proof if you combine these two into one. You can do it either way. Pretty good on that? All right. Then in 5.6, 2 more shortcuts. Remember it was angle, side, angle. Remember the side, this has to be the included side. So remember, it's going to be the side that's in between the 2 angles that have the congruency marks. And then the other one was the angle, angle, side. And this one is not the included side. And then the last section was just the Cpctc. So in here, Cpctc, which again stands for, the first C stands for corresponding. The next P, or the P, is for parts. And then of, and then it's congruent, and then triangle, and then congruent. So that's what each one of the letters in the acronym stands for, Cpctc. Corresponding parts of congruent triangles are congruent. That's what it stands for. So you would use this after you've already proven that the 2 triangles are congruent. So all of these examples in this review are good ways to practice for the test, in addition to using your warm-ups, your notes, your homework. Now on the next thing that I have here, this is the other review that I posted. Here, notice I took off 5.8. So in the file that's posted on Canvas, it still had 5.8. Don't worry about doing that. 5.8 is not on the test. So on the next slide, so this one again is good. Remember, I told you to skip anything that had 5.8. So now, if you go back that I have here, this is the other review that I posted. It's listed in the assignment as extra review. So here, just get rid of, you don't need to worry about questions 9, 10, and 11. You can skip those if you're trying to look for more practice problems. And then I just put in here a screenshot of that shortcut. This was actually in the notes from 5.6. And these are your 5 shortcuts, or ways to prove that 2 triangles are congruent. Remember, no ASS or no SSA. On the test, I'm going to list these, so you don't have to worry about remembering the acronyms. So on the test, I'm going to say which one of the shortcuts proves these 2 triangles are congruent, and I list the 5 things. And all you're going to do is put either the 2 letters if it's a hypotenuse leg, or the 3 letters. Okay, so similar to what we did in the 5.6 warm-up. Pretty good on that? All right, so this is your overview of what's on the test. Again, 16 questions, 2 proofs that you're writing all by yourself. They will be very short and basic, no more than 5 steps. Okay, this is assuming that you're putting all of your given in one statement. If you put your given in more than one statement, then obviously you're going to have a lot more steps. All right, everybody good? Any questions? Yes.